Hello guys, welcome back to my class. So in the last lessons, you have learned one of the quite important control structure, which is the selections. So today I'm going to teach you another type of a control structure, which is looping. And looping is one of the quite famous and commonly used method in the programming world. So at the end of this lesson, you should be able to know what are the techniques that are available in the looping and some mistakes that commonly made by the programmer. Okay, before we move on to several types of these loopings, so I would like to explain briefly what is the looping first. So basically, a loop is by definition is a group of the instructions that the computer executes repeatedly while some looping continuous conditions remain true. So in other words, a loop structure is a construction that repeats a statement or repeats a block of this statement. Okay, so such as you are attending a gym sections to build up your muscle, your coach is instructing you to do 12 times of this squatting, 12 times of this bench press, 12 times of this push-ups. So you repeatedly do the same task. So you know what is the looping by definitions, right? So now let's apply this looping in our C++ programming world. We have four different types of loopings, but here I will show you two first, known as the pre-test and post-test. So in the pre-test looping, the conditions is checked first at the beginning of each of the iterations. So from the flowchart, you check the condition first before you perform the task. And as long as the condition is true, then you keep repeating to do the same task until if you do meet the condition, then you come out from this looping. Okay, so come back to the real situation just now. So your gym coach is instructing you to do squatting for 12 times, right? So before you start, you have to compare the number of times that you have done for this squatting with the instructions from your coach. So at the beginning it's 0, nothing, you do nothing, right? So you compare to the instruction from your coach, which is 12 times. So 0 compare with the 12 times, is it less than 12 times? Yes, true. As long as the condition is true, then you go into this looping, perform the action. Okay, then you do the squatting for first time. Okay, done. Then you have to check the condition again. So compare with this 12 times, is it 1 less than 12 times? Yes. Then you keep repeating because you still haven't fulfilled the conditions. So you continue the process, and then this number of times here in the programming world, we defer it as iterations or the loop. Okay, number of iterations. You do 12 times means you do 12 iterations. Okay, so somehow you continue until this 12 times, and you compare to this instruction again. Is it 12 less than 12? No, it's wrong. So you fail to meet these conditions and you come out from this looping. You terminate this looping. Okay, and this structure is possible not executing any action at all. So meanwhile, in the post test, okay, the condition is checked at the end of each of these iterations. Okay, this is the flowchart. You perform some action first, then only you check the condition. As long as the condition is true, then you repeat the same task until you fail to meet this condition. You come out from this looping. Okay, so come back to this realization. You do the first squatting first, then only you check the condition. Is it 1 less than 12? Yes, true. Then you perform the same task again. Do the second squatting, check the conditions. As long as the condition is true, you have to repeat until you fail to meet certain conditions. Then you come out from this looping. Okay, so in the looping, there are three very important parameters where you have to always remember whenever you are using this looping control structure. Okay, and these three parameters are initializations, check conditions or loop conditions, and finally check conditions. So this initializations is the initial conditions before the checking conditions. Okay, so in the beginning stage, you haven't done any exercise, any push-up yet, right? So your counter will be 0, start with 0. Okay, then you check with these predefined iterations or predefined conditions, which is 12 times instructed by the coach. So you check, is it 0 less than 12? Yes. Then you fall into this looping. Go to the actions, do the push-up. So each time you do the push-up, you will update the counter by 1. Okay, and this counter, we call it as a updating conditions. So you keep repeating until your counter reach 12 times. So is it 12 times less than 12? No, wrong. So you fail to meet this condition anymore, then you stop the iterations. You come out from this looping and tired, take a rest. Okay, so it is very important to write your initialization, conditions, and updating statement correctly. Otherwise, the looping will either never repeat or never stop, or fall into this endless loop. So look at this program. We have this initialization 0, check the conditions, count less than 12, push up, stop here. We have no updating conditions. So what happens? You are falling into this endless loop. Okay, so whenever you are using this looping control structures, always put this remember, so you have to put this initializations, check the conditions, and finally update conditions. Okay, so let's look at this example. Go to this top right corner, your online compiler here. Okay, we have it as recent program from the slides. So while count less than 12 to push up, so I forgot to put this updating conditions. So I run the program, so let's see what happens. Okay, you will keep printing this push up for me because I forgot to put this update conditions. So you this count will remain 0 less than 12 through push up. Okay, go to here, 0 less than 12, yes, keep printing this put up. Okay, and let's do. So you have to add the counter. Remember, always initialize the counter, check the conditions, and finally put this updated conditions counter count. Okay, so you just print the 12 times push up for you. Okay. Okay, so beside the pre-test and the post-test looping, so basically we have another two type of looping here. We refer it as event control loop and counter control loop. Good. So let's talk about this counter control loop first. So this counter control looping is the looping that's controlled by the number of counter that's set by the user. So just like the previous case, so we stop these actions when the counter reaches a certain amount of the iteration rights. Set 12. So as long as your initial counter is your counter is less than 12, then you perform the task. Then you add 1. Everything is depend on this counter. You start based on this counter, and you terminate this action based on this counter also. That's why we call it as a counter control loop. It's controlled by number of counter that's set by you. Okay, so now come back to this event control loops. So in some occasions, we don't really depend on the counter. We don't stop based on the counter. Okay, we can't use the counter to decide when we need to stop the iterations. Okay, in this event control loop, the loop will be terminate when an event change the loop control expressions or the conditions from true to false. Okay, for instance, we are in a house auctioning hall. Okay, and the reserve price for this auction hall is 200k. Okay, and this auctioneer will start to ask anyone who would like to bid the house, start to bid. So there's a one bidder respond, I say yes at 50k. So add number to total. Okay, so your new price for this house is 250k. So the auctioneer will ask again, any response? So yes, there's a response from this bidder at another 50k. So as long as there is a response, then you have to repeat the task. Okay, then the auctioneer asks any response after this 300k. Okay, no more response. Okay, means the condition is false, no more response. So 1 2 3, so okay, so get out from this statement, get out from this event control loop. So in this case, we don't have the counter, we stop the looping based on the event. Okay, from here respond either yes or no. Okay, so I hope you can identify or differentiate this counter control and also this event control looping. Okay, so up to now you have learned about these 4 different types of looping. We have a pre-task and a post-task, event type, and a control type looping, right? So now we will move on to this coding technique that will perform this different type of looping, which are while, for, and do while loops. Okay, so when you need to use this while, when you need to use this for, and when you need to use this do while loops. Okay, let's move on to this next slide. Okay, if you have a situations where you have to test the condition first before you start to perform some task, and it is either can be a control or a counter event, then this while loop is a choice for you. Okay, where the action is run repeatedly while the condition is true. Okay, you have this condition, you check, as long as true, you perform the task, repeat until you fail to meet the conditions, then you come up from the looping. And here is the syntax: while, and this is your conditions, put the brace for your statement. If your statement is just a single line, then you can just omit this brace. Okay, so here we have one example here. Write a program that finds the value of 2, multiply itself 10 times using this while statements. Okay, so remember the 4 steps that I mentioned in the lesson 1 to write a good program. Okay, you have to understand the problem first. So from these questions, we know that you have to write a codings that to calculate this 2 multiplied by 2 repeat for 10 times. Okay, and then to give you the result. What is the result for this 2 multiplied by 10 times by itself using this while loop? Okay, once you have understand these problems, the next step you have to identify the 3 parameters that I mentioned earlier when you are using these looping control structures, which are the initializations, the check conditions, and your update conditions. Okay, so what is your initial value? So in this case, you need a counter which is 0 and a variable stored as 2, as you need this value to be multiplied by 2 itself later. Okay, then we have a conditions. So this condition is normally the number of the iterations or the last value for your iterations. So in this case, which is 10 times. Okay, and finally, remember to put this update condition count plus plus. So increase by 1. Okay, increase by 1 for 10 times. Okay, and perform some tasks. Okay, next questions. write a loop to print out the even numbers from this 500 to 2. Okay, so first understand the question first. Right? You are required to use this while loop to print out this value start from 500, and then 498, 496, 494, because even numbers, until finally 2. Okay, next, once you have identified understand these questions or problems and what are the expected output, identify your initial value, check condition, and update conditions. So in this case, your initial value will be 500 because the first value to be printed is 500. Then checking the condition will be the last value in the iteration, which is 2 here, the last value. Okay, as long as the value is more than 2, then you print out this value, and then you have this update conditions. Okay, so update condition is subtract 2 from the counter. So a tips here, this updating conditions is normally the difference between the next value and the current value. Okay, for instance, you have this 498, this is your next value. What is your current value? 500, right? So you minus this 500 with this 498, you will get 2. So your update condition will be 2. So finally, convert to this C++ programming using the syntax. Initial value 500, the condition is more than 2. As long as it's more than 2, then proceed. Then your update condition will be minus 2. Okay. Okay, so we have a question here. Try this. Write a loop to print the sum and the average of these event numbers from 2 to 10. So understand the question first. Okay, once you have understand these questions, identify what is the initial value, check conditions, and update conditions. And then finally, write your program. Okay. Okay, so there is a situations where you can't really use the counter to decide whether you want to stop a looping or not. Okay, we don't really depend on the counter to stop the process. Instead, we stop the looping if there is some events happen. Okay, for instance, when the user need to key in some special predefined value to stop a looping process. Okay, and this value we call it as a Sentinel value. Can you refresh the slide in the page 16, the auction case? Okay, the process is stopped based on the event, based on the is there any response or not from the bidder. Okay, it's not based on the this counter. Okay, so we have an example here to stop looping, to come up from the looping using this Sentinel value. Okay, look at this example. Okay, we are asking the user to key in the file name. Okay, to key in the file name, and if you want to exit this program, you have to enter this exit. This is the Sentinel value. As long as the user didn't key in this exit, this program will keep repeating, perform the same process. Okay, look at this example here. Look at this programs. So I run the programs. Okay, now asking the user to key in the values, to key in the file numbers. Okay, file number 1. So I click enter. So this file number 1, is it not equal to Sentinel value, which is exit? Is this condition true? Yes, true. It's not equal to this exit. So it will go into this looping, continue asking the user to key in the file name, file number, file 2. So again, it will keep repeat this same process. Okay, until the user write this exit, then it will come up from this loop, stop everything. Okay, so we have another example here, same. Enter a score. To exit this program, enter 999. Okay, as long as the score is not equal to 999, you will just proceed until the user key 999, then program end. So log address online compiler. Okay, please enter a score. I run the program first. So please enter a score. To exit the program, enter 999. So I enter 56. Is this 56 not equal to 999? Yes, this condition is true. So we fall into this looping, continue, perform this task. And then done, you will come back to this conditions. Okay, ask again, I key in another value, 98. Repeat again, keep repeating until you key in this, until you think that okay, that's all for this score. I want to exit this program, so I enter 999. So program ended. Okay, in both these examples, the looping process will just keep going on, keep repeating until we key in some Sentinel values. Okay, we don't really know what is the final value, or we don't know the counter to stop the process. So as long as the user not keying this exit on 999, the process will be continue. Okay, this we call it as a event control looping. Okay. Okay, let's move on to the next looping technique known as the for loop. Okay, normally we use this for loop. We have situations where you need to test the condition first, and when it is only a counter control event. So look at this flowchart. It is actually same like the while statements. The difference here is the syntax, where you put all this initial value, check conditions, and updating after this for statement. Put a bracket, include all these conditions, and then no semicolon at the end of this for statement. And then you perform the actions. So here is the example, same as the while loop. We have three major components: initializations, check condition, and update conditions. Okay, so basically the for loop is actually same like the while statement for counter control loop type. Okay, however, this for loop is much easier to read and more natural for this counter control loops. So okay, here is the comparison between this while and the for loop. Look at this while loop first. We have this initial value 1, I equal to 1. Check the conditions. Is it I less than 10? True. It's true, then enter this looping. Okay, perform the task, update the conditions, and check again. Okay, so meanwhile in the loop for loop, you have an initial value, check the condition first. Okay, perform the task, update the conditions, check the condition, perform the task. Okay, repeating. So both will produce the same output, but this for loop is more suitable, okay, for the counter event control. So we have an exercise here. Okay, write a program that reads a number. You use the for loop to display a list of integer 1 up to the number, up to the limit that user key in. So this is the expected output. Please key in a limit. So I key in 3, then you will start to print out start for initial value 1, and then increase by 1, 2, and increase by 1, 3, and so on until the limit that entered by the user. Okay, so when you understand these questions, identify what is your initial value. Your initial value will be 1. What is your check condition? Your check condition is as long as it's less than this limit. And finally, what is your update condition? Your update condition is normally the difference between the next value and the current value, which is 2 minus 1 equal to 1. Okay, so this is your program writing. Enter the limit. So I will be a limit. As long as it's less than this limit, then you perform the task, and you increase this counter the limit by 1. Okay, so I want you to try this exercise. Understand the question first. What a for loop to print out these following integers in a sequence. You have the initial value of 5. Okay, you know that you have an initial value of 5. So what is your check condition? Your check condition is normally your last value for this iteration, which is the 50. Okay, And what is your update condition? The update condition is normally the difference between the next value and the current value. So 10 minus 5 equal to 5. So try this question by yourself. Okay, now let's move on to the last technique in this looping structure, which is do while loops. And it is suitable for only post-test conditions, which means you want the program to execute the body for at least one time, and it is a event control loop. Okay, so here is the syntax for this do while loop. You perform some action first, then only you check the conditions. As long as the condition is true, you continue to perform the task until it fails to meet these conditions, then you come out. Okay, and here is the syntax: do, put a bracket, and this is your statement for your actions. Then only you put the check condition, while bracket conditions. Okay, now let's see what is the difference between this while and the do while loops. Okay, I have a question here. Convert the following case in while to do while loop. Remember what is while. Okay, while loop is a pre-test loop. The condition is test first. Here we test the condition first, then we perform the task, we update the conditions, we test the condition, we repeat. Okay, so how to convert this while loop to do while loop? Pretty simple. What is the syntax for this do while loop? So here we have the syntax for this do while loop. Okay, now identify the initial value and the content here first. Okay, we have this initial value 1, and this content remain the same, put at the top of this do while loop, and we have to put the content inside this do while loop. Okay, and the main difference here is the checking conditions. Okay, so instead putting after the initial value in this while loops, these conditions you have to put after the perform task, because this is a post task. Means that at least you have to perform the first task or the one task first, then only you check the conditions. Okay, so try this out. Convert this for loop technique into this do while loop. Okay, so my hints here: always identify what is your initial value, checking conditions, and your update condition first, and recall back what is the syntax for the do while loop, then only you do the conversion. Okay, one of the most commonly used applications for this for loop is to accumulate the total in some repeated calculations. For instance, you are having a grocery shopping now, and you bought 4 items. Now you go to the counter and make the payments, and the initial total value will be 0. And then the cashier start to scan the first item. The total price will be accumulate 120. Scan second item number 2, add 250. Now you have 370. Scan the third item, and so on. And finally, to give you the total. Here is how the coding look like for this for loop in a total accumulation applications. So this is your accumulator total 0, and you have a initial value counter 0, item 0, start from 0. Okay, is it less than total 4 items? Yes, you proceed to calculate enter the price, calculate the total price, add a counter by 1, then your item number 2, check is it less than 4? Yes, then proceed, and finally you will get the total amount for these 4 items. Okay, so another common application here is the nested for loop, where you have a for loop inside another for loop. Okay, this nested loop makes the program logic gets more complicated. Okay, here is the syntax for this nested for loop. We have discussed the syntax for the for loop in the other sections. So basically, you just have another for loop inside this for statement. Okay, the inner one we call it as a inner for loops, and the outer one we call it as a outer for loops. Okay, and one of the biggest mistake that the beginner make while using this nested for loop is they don't even understand the principle for this nested for loop. So here I'm going to show you quite a good examples so that you can understand how this nested for loop actually works. Okay, so imagine that you have just signed up a package in the gym center to build up your muscle. Okay, and the duration for this package is one month. Okay, and every day per week. So you can think that this 1 month will have 4 weeks, right? 1 month we have 4 weeks, and each week will have 5 days. Okay, so in this case we have two variables, week and day, weekday. Which unit is bigger? Week, right? Week is bigger than this day. So put this week as your outer loop and the day will be your inner loop. Okay, so this is how the program goes. For I will be your week, and I put J as your weekday. Okay, how many weeks? 4 weeks, right? So my check condition will be 4, and days, the check conditions for this day will be 5 because 5 days. So now we have week number 1. Come to here, check out, see out. Week number 1, come to this inner loop, day 1. Okay, day 2, 3, 4, day 5. Okay, fail to miss conditions, come out from this inner loop. Okay, come out from this inner loop and then go to the week number 2. Okay, and come out from this week number 2. Okay, repeat again, week 2, day 1, 2, 3, 4, 5. Week 3, day 1, 2, 3, 4, 5, and lastly week 4, 1, 2, 3, 4, 5. Okay, so clear how to use this nested loop? Okay, if not, then don't worry, we have another example here. You would like to print out the alias pattern in 2 dimensionals, 4 rows and 5 columns. Okay, 4 rows and 5 columns. So in this case, you can decide either use this row or number as your outer or inner loop. It doesn't matter. Both will produce the same result. Okay, first thing first, you have to identify. Okay, there are how many rows? 4 rows, 5 columns. Okay, so I will use this I represented by rows and J represented by column. I have 2 variables here. So in this case, I will put this row as my outer looping and this column as inner looping. So this is how it looks like. Okay, initial value 1. So I is your row number, right? You have how many rows? 4 rows. So this is your check condition 4. Meanwhile for J is the column 1. You have 5 columns, so less than 5. And this is how it works. You have, first thing first, you have 1. First start from the first row. Okay, go to this first column, repeat, second column, third, fourth and fifth. Done. End. Okay, then you print out C out and print out a new line. Come out from this inner loop, go to the second line. You have row number 2, which is I number 2. Repeat 1, 2, 3, 4, 5. Okay, then you fail to meet the condition, come out from this loop, print a new line, go to the third row, 2, 3, 4, 5, and so on. This is nested for loop. Identify which variable to be your outer looping and which variable to be your inner looping first. Then identify this initial value, checking conditions and update condition for each of the variables. Okay, so I have an exercise here. Try this out. What is the output for this following code? Okay, understand what is this inner looping and outer looping, and then comment the answer in the section below. Okay, So congratulations, you have learned this for loop, while loop, and do while loop. Now let's move on to the last part in this lesson, jump statement. Okay, the purpose for this jump statement is to terminate the loop or to skip some statements within the looping when some certain condition is true or is met. Okay, it is normally used for this input validations together with this if statement. Okay, we have two types of jump statements. We call this as a break and continue statement. So what is a break statement? Break statement calls immediate exit from a structure. It's a program execution continues with the first statement after the structure, and it is applicable for all the techniques in this looping control structure and the switch statement. Remember what is switch statement? This is a selection statement in the previous lessons. Okay, so look at this case. Asking the user to key in 5 positive number means that you are repeating. Okay, repeating to key in the 5 positive numbers, but you have to do some input validation. Make sure the user key in some positive value. So inside this while loop, you have to put this if statement as an input validation. If the number is less than 0, maybe the user key in a wrong number due to the mistake, it puts some negative value, then break. It means that it will stop this statement inside this while loop. It will stop everything. Okay, it will not execute any statement anymore inside this while loop. It will just go to the exit from this loop and proceed with the next line in the main function. Okay, so remember, you will not execute any line here if the statement is break is executed. Okay, you will stop everything, come out from this looping statement, block statement, come out, execute for the next line. So here are the example in the online compiler here. Enter 5 positive value. So I run the program. So enter a 5 positive number, 65, 78, and then accidentally I key in a negative, I don't know, okay, due to the human mistake. Okay, 48. Then it will stop everything. You will not execute the lines afterward, after this break statement. No. Okay, you will not continue with the next iteration also. No. You will straight away stop everything, jump out from this looping, and then go to this line. Alright. So meanwhile, for this continue, the looping is still continue, although the value that the user insert is violating the condition of the looping. Okay, the continue statement will skip any remaining statements in the body and proceed with the next iterations of the loop. Okay, and it's applicable for all the looping technique, while, for, and do while. So here is the condition. Here is the examples extended from this previous examples. So I just changed the break into the continuous. So remember what is the definitions. If this continuous statement is executed, it will just skip the remaining statement. It will just skip the remaining statement, but we will still go back to these iterations and proceed if the conditions is violated. So look at this example here. Okay, we have a continue. I run the program. I key in the first value 78, 98. Again, I put a negative value 90. Okay, it will not stop. Instead, we'll just stop this else statement and come back to this iteration until you key in this 5 positive value. So if I key in a negative value, it will keep repeating, asking me to key in a positive value. Okay, until I key in a positive value. done. I key in 5 positive value, then only it will exit from this statement, go to this cout. Okay, so this is the difference between the continue and also the break. So in the break, if I have a negative value, you break the you violate these conditions, you will stop everything. Okay, for this while loop. Meanwhile, for this continue, although you violate this condition, it will just stop this remaining code here, remaining statements, and continue with this iterations until you have key in 5 positive value. Okay, so I hope you understand the difference between this continue and the break, right? Okay, so that's all for today's lessons. Okay, I hope you have learned something new for this class, and if you like this video, please give me a like, and I will see you in the next lessons.